Hello and welcome to this week's edition of Engineering and You, a program where we get to bring to you people, engineers, as a matter of fact, that have done well for themselves in the field of engineering, with a view to encourage young Nigerians to take a career in the field of engineering and make the world a better place, like I used to say. The program is sponsored by Prince Engineer Yemisi Shidon, FNSC, and supported by the Nigerian Society of Engineers, Abeokuta branch. And on this program is a very interactive one, and we get to ask you questions, we get to answer our questions, and get to win a prize courtesy of Prince Engineer Yemisi Shidon. And the question for the day, let's go straight into it, is the following are the uses of radioactive isotopes except for A, sterilization of medical equipment, B, tracing of reaction path, C, dating elements, and D, radiography. The following are the uses of radioactive isotope except for sterilization of medical equipment, tracing of reaction paths, dating elements, and radiography. If you know the answer, pick up the phone and call us, or you go to our Facebook D, then we know if you are correct or not, and you get your prize courtesy of Prince Engineer Yemisi Shidon. My guest is already in the house, and I would not want to keep you waiting because we are going to be discussing something that is very important to living and livelihood. And I won't let the cat out of the bag, but I would take this very short break. That's the question on your screen. If you know the answer, please just call us. Just mention the option A, B, C, or D. And if you are correct, we'll let you know. My guest is in the house. We'll take this break right now, and then when we return, we'll let you know. I'll let you know who my guest is, and we'll take it off from there. Welcome back. My guest is Engineer Dr. Adedayo Adekunle Badejo, and Engineer Badejo had his national diploma and higher national diploma in civil engineering, and from the Federal Polytechnic Ilaro in 1992 and 1995 respectively. He holds a BSc and MSc civil engineering and PhD in water resources and environmental engineering from the University of Ibadan. He had his postdoctoral research following a fellowship at Shan University of Technology, Pretoria, South Africa. He is registered with the Council of Regulation and Engineering, COREN, and a member of the Nigerian Society of Engineers, NSC. He joined the service of the Federal University of Agriculture, Abeokuta, as an assistant lecturer and rose to the position of an associate professor in 2022. In 2020, I beg your pardon. He is well published in reputable local and international journals. He has attended and presented papers in both local and international conferences. He has 53 journals, articles, and proceedings with a patent title, Constructed Wetland Technology to Treat Domestic Wastewater, Septic Tank Effluents, and Industrial Wastewater. He has won the National Water Capacity Building Network grant on nature-based solution for water. Can go on and on and on. Engineer Badejo has a lot of things to his credit. And Badejo, welcome to Engineering and You for today.
Thank you for having me.
Now, he's going to be discussing a very interesting topic. Like I said earlier on, is something that is we need for life, and that is restoring the declining resources, the water engineer's perspective. That's the topic he'll be discussing in the next maybe 10-15 minutes. And get your questions ready, because I won't let you answer my question until you have asked my guest a question. So, Engineer Badejo, can...
Thank you so very much once again. I'll be discussing the topic restoring declining resource. And the resource we are talking about here is actually water. Because we use water for so many things. There are people that use water for irrigation. Some use water for maybe cooling their engines. Some industries, they use water for maybe manufacturing of some of the products that they have. So basically, we need to restore it. Because somebody like, when you go to somewhere like Adaton, you see people producing this locust bean, Iru, the normal Iru that we use. And they just discharge into the receiving stream without treatment. You go to places like maybe Itoku, go to places like Ashero, you see people producing maybe Kampala and Adire, they just discharge without treating. So much, there are so many places that if we go to industries too, you see people there, they will be producing some things and they will discharge without actually treating. There was a time even the Ogun government had to enforce it, that if you have an industry, if you have a company, make sure as much as possible you have an effluent treatment plant. So there is need for us to actually restore it. If not, we just discover that, thank God, God has blessed us in Nigeria. That's why we are not having challenges with water. But there are some countries that they have challenges with water. And because of that, they have to make sure that water we refer to as waste, they will have to convert it again. That will be what they will now treat. That will be what they will now pass to their dam. That will be what they will now pass to their water treatment plants. And that's what they will consume again. So basically, there is need for us to restore it. Because so many areas, like it has been reported that close to 90% of wastewater produced globally remains untreated, resulting in widespread water pollution, especially in low-income countries. So how do we now go about, why do we need to restore it? Number one reason we have to restore is to enable disposal of wastewater safely without endangering public health, polluting water courses, or causing other nuisance. Because basically, if you discharge without treating, there are some people that will maybe use the water for some things at the downstream. And when they use the water, if they are not aware that you have discharged something that has some toxic elements, some things that are pollutant, there's a tendency that is going to affect what they will consume. So there is need for you to treat, so that those that will be taken, even the aquatic life, because sometimes we are not particular about aquatic life, we just look at ourselves, that we have used it and it has served us. Based on that, we can just discharge. But we have to be particular about those that will have access to the water. Another reason is we need to recover energy, nutrients, water, and other valuable resources from water. What we have discovered is there is no waste anywhere. The way God created everything, if you can recycle it back, you can even turn your waste to wealth. Those things that you are referring to waste, some people can use it, just like treatment plants that we have. If an example, activated sludge, for each of the stage that we have for the treatment, there is something there that you can take out of it and use. Like you can, if I talk about the preliminary stage now, wastewater treatment, that is the aspect of screening. In that aspect now, I can get what we refer to as screening, and I can use that to generate my biogas. When we get to the primary treatment too, you have sludge, you have scum. The sludge there can also be used for some other things. So there is nothing that is a waste. You can convert that thing back. And some countries that are water scarce, is the water they produce, they use as their wastewater, they will now convert again to the water they drink. Another one is to comply with legal standards and consent conditions. You know, now we have so many regulatory bodies, like in Nigeria we have Nestra, we also have WHO outside. We have so many standards that we need to actually discharge without the actual treatment. So there is need for you to get an engineer that will help you in the designing, in the development, and at the end of the day, help you in the construction. So what are the different methods that we have? Like, you know, we generate waste everywhere. In our different houses, we have waste. So we have the non-network individual treatment methods. We have the central network treatment. Come and carry your waste, your sewage that you have generated, and at night they will put it inside their tanker and they will take it. That's an example of a removal method. Also, this man along Lagos Ibadan, I think he called it Otumba Gaddafi or something. Okay. He said cheap business is good business. Based on the fact that he's using removal method. He has all these mobile toilets. He will take it, if you're having any program, he will put it there, he will take it there, and at the end of the day, he will remove it. That's an example of removal method. There's another one we call infiltration. That's what we are familiar with. Something like this soak away pit, privy latrine, aqua privy, so many of them. Those ones are infiltration method, because at the end of the day, you first collect in the septic tank the solids and the liquid aspect. Then the liquid aspect will go to the soak away. Is a form of infiltration method. There's another one, destruction method. Then the central one. In advanced countries, most times they don't deal with all these individual methods, because individual you have to treat on site, you treat in situ. But when you talk about the central aspect of it, you can connect everything, all the ways that we generate. Maybe in all the local governments that we have in Abeokuta, we have a central treatment plant there. And there are so many methods that we can use. And what we have discovered is that all these methods too, they have advantages. And there are some that they are selective in nature. And one of them is the activated sludge method. That one, we need so many things. We need to get a container, that might be as big as the entire complex of OGTV. You need to get something that will agitate the waste. Then you need to recycle your sludge back. That's activated sludge. Then there's something we call the trickling filter. We make use of just trying to allow the water to flow through some cobbles. At the end of the day, you have the fixed film there that you'll be able to treat your waste with. You also have the stabilization pond, and that's what we use in all these old universities that we have. If you go to OAU, you have a stabilization pond there. In front of UI to Abeokuta, you have a stabilization. Then the one we actually laying emphasis upon now is the nature-based solution. And that's the one you don't need to, like, we have issues most times with power supply. So if you don't want anything that will involve anything related to using, because most of these ones I've talked about, so you need electricity. Where I did my postdoc, as much as they spend close to quarter of what the entire province use for the treatment plant. So if you want something that will not need electricity, that will just be natural. So what we do most times is you have an equalization basin, you pass the water there. It might be from different places too. You connect everything together, you pass the water there. From the equalization basin, you send it straight to your treatment plant. And that's why we have something like a ridge bed technology. You have constructed wetlands, so many of them. And all these ones too, things that people refer to as a nuisance to the community, just like water essence now. There are some places that you consider a nuisance in the community, but we can use it to treat our waste. There are times we even have maybe like canal lily, just as if you're having flower at the back of your house, and it's treating the waste you are generating, and that waste could be recycled back to the system. So talking about the natural based, most times we refer to wetlands as the giant kidney. If you have wetland anywhere, you have maybe sand inside the wetland, you have plants inside the wetland, they do the work that kidney does in the body. They try to filter the waste inside. So that's what we actually use here. Because we use a method we refer to as the fixed film. We expect there are some microbes that will be there. We expect that we can design to the extent that if we leave the wastewater inside the tank for some time, what we refer to as a retention period, that thing will be treated. So the constructed wetland is an engineered system designed to utilize natural process for water quality improvement. It combines physical, chemical, and biological treatment process in water quality improvement. So you have to put all these things into consideration before you now treat. Because for our treatment, most times we consider the physical. We consider how is it because of the weight that the thing is settling down? What is the quantity of sludge that we get? Is it because of the density that is floating? So most times, these treatment plants, it can also remove heavy metals. There are times they will tell you, this one can remove this one cannot remove this. But when you talk about this treatment, constructed wetland, it has a tendency, depending on the plants you are using. There are so many plants we have discovered that they can actually remove some of these things and to conform to regulation when you are discharging to the stream. So basically, I want to round it off with the issue of, because looking at wastewater engineering, some of our younger ones will be looking at is, how can I be involved in wastewater engineering? It's an aspect of civil engineering, because civil engineering has so many different branches. We have the structural aspect of it, we have the geotechnical aspect of it, we have the traffic and highway aspect of it. Even there are some places that refer to it as public health engineering. There are some places that refer to as sanitation engineering or sanitary engineering. So basically, it's an aspect. In Nigeria, most times, the area we can, our younger ones can emphasize on is the water resources and environmental engineering. Under that now, you'll now be able to specialize. Because when you look at waste is everywhere. You can talk about the solid waste, you can specialize there. You can talk about this liquid waste, you can specialize there. There are some gaseous waste too that we can specialize there. Then the aspect of the waste, the water resources is all encompassing. Because you can also be a water resources engineer, be particular about the hydraulics aspect of it. You can be a water resources engineer, look more about hydrology. You can be a water resources engineer, look more about what can this thing produce for us. Because water is, we used to say, water does not have enemy. Every one of us use water for so many things. So I want to actually encourage our upcoming that civil engineering is, they should take up civil engineering. Civil engineering is a creative and challenging profession that offers the utmost opportunity for every individual to display his or her vigor, ingenuity, and non-violent aggressiveness. The greatest engineering opportunity in this nation are not behind us, but still lie ahead for young people with talent, with vision.
We have a caller. Hello.
Hello.
Hello, good evening.
Yeah, good evening.
How are you?
I'm fine, thank you.
Okay, I'm sure you have a question for my guests. What's the question?
No, I want to answer the question. My answer is A.
Okay, but you need to ask my guest a question before you can get my prize, if you win.
Okay. I just want to know if
All right, let me allow you go. Thank you very much for calling. All right.
So basically, talking about wastewater engineering, we've discovered that there is no way we can live in this community, in this world we find ourselves, without converting something back to the natural form they've been before. And we need somebody like somebody that is involved in this engineering aspect of it. How do I collect it from where it's being produced? How do I design my sewer? How do I pass my sewage into it, so that at the end of the day there won't be issues? Because where do I position it? Should it be on the same side with my pipe for pipe-borne water? Should it be upstream? Should it be downstream? So all those are the things that a civil engineer that is involved with wastewater engineering will do. Then what is the best method? You know, there are times you discover that based on what they are producing, you have to get the actual method that will be required for that treatment. So, like in wastewater engineering, we have so many different plants that we have. There is Phragmatis caca, there is Typha, Latifolia. There are so many of them that we have discovered that they are selective in nature. Some can remove chromium, others will not be able to remove chromium.
Okay,
so,
let me take you up from where you stopped. Now, are there regulations in this country that clamp down on these industries that just discharge wastes without considering the harm that it would have on the people?
Thank you for that question. Basically, there are regulations. Like we have Ministry of Environment almost everywhere. Then there is this NESTRA, National Environmental Standards and Regulation Enforcement Agency. They are the ones that are supposed to be looking at what they discharge. Because if you discharge it...
We have a caller. Hello, good evening.
good evening.
Good evening. You're welcome.
Please, I want to answer that first question.
Okay, what's your answer?
B.
You said?
B. My question is B.
B, all right. I will let you know if you are correct or not. Thank you so much for calling.
Okay. Bye-bye.
All right, thank you so much. All right, you were answering.
Yes, the issue of regulation, there are so many. Like even outside the country too, we have bodies. We have even the minimum they are supposed to discharge. We have so many regulations there. But basically, the problem is most of them. Like when you have a company and you are producing something, you are supposed to have an effluent treatment plant. It might be small, it might be big, so that you will be able to conform to that regulation, to the standard that is required. But most times they want to construct it based on the fact they will consider the cost. They will look at some of them. We will have what we refer to as the non-point and the point and the non-point system of discharge. There are some people they will go and discharge it where you will not be able to actually identify that they want discharging it. Ordinarily, when you have a company and you are using water, the standard is before you discharge this, make sure it conforms to what is expected. But most times people don't follow the standard. But there was a time when the state government was actually
we have a caller again. Hello, good evening.
Hello, good evening.
Hello, good evening.
Good evening.
How are you?
Fine.
All right, you want to ask my guest a question, or you want to answer my question?
Both of them.
All right, go ahead.
The water we recycle, is it consumable?
Okay, the water that is recycled, is it consumable? All right, what's the answer to my question for today?
C.
C. You said C, right? All right, thank you so much for calling. Water that is recycled, is it consumable?
It depends on the extent of treatment. Ordinarily, you can recycle water and use it for irrigation, but if there are places that, because of the fact that they don't have access to enough quantity of water, what they do is, after the treatment, you will now pass it, because we expect that if you discharge water into a stream, that is what we call auto-purification. By itself, water will purify itself. They will now pass it to their dam. They will allow it to be there for some time. They will now abstract it from there. They will now pass it to their water treatment plant. It will go to all the different stages that we have in water treatment. It's consumable. But it depends on the extent of treatment. There are some places that when you go to some wastewater treatment plant, you might be tempted after seeing the water that comes out of the maturation pond. You might be tempted to start drinking the water because it will be clear. But you have not actually tested for all the necessary components that is required to meet up with the drinking water standard of Nigeria. But it's consumable if you have actually passed through all the treatment that is required.
All right. There's so much question I would like to ask you, but our time is actually running. But let me just ask you this before. Okay, we have a caller. Hello, good evening.
Good evening, sir.
Good evening. How are you?
Fine.
Okay. You want to ask my guest a question?
No, I want to answer to the question.
All right. What's the answer to the question?
My answer is C, which is dating element.
C. All right. I'll let you know. Keep watching. I'll let you know if you are correct or not. All right. Thank you so much. All right. We have to go now. But I want you to give. This program is sponsored by Prince Engineer MC Shillon. I'm sure you are aware. And I want you to bear your mind is sponsorship of this program to encourage young people like they have been seeing them calling. What do you feel about this program and the sponsor?
Sincerely, Engineer Shillon is a great elder. He's doing a great job. I will at every time doff my cap for him. Because to a great extent, if not for programs like this will actually make people see the need to actually go into engineering. I really salute this and I give him kudos.
All right. Thank you so much for coming, Engineer Badejo, for coming to Engineer for today. We really appreciate it. I wish we had enough time to talk, but we have to go now. And we have to go. And our question for the day, Olayinka, right? The answer is A. The answer is A. And sterilization of medical equipment is not part of the option. Then our question for the week. Let's continue on social media as we continue with this answer to the question: which of the following is a neutral oxide? Okay. The following are the uses of Which of the following is a neutral oxide? A. Nitrogen oxide. B. Carbon 4 oxide. C. Sulfur 4 oxide. C. Phosphorus. If you know the answer, please send your answer on those social media platform on your screen, and we'll get your prize across to you. For Olayinka that called us from Shagamu, you can call this number to claim your prize: 003 684 7505. That is 003 684 7505, and get your prize. Courtesy sponsor Prince Engineer Shillon. I have to go now. Thank you so much for watching every week, and next week is another opportunity. Join us then. Until then, my name is Donald Niro. Bye bye.